Leet code question number 392 is subsequence. Let's start. This is easy question. Let's check into it. Given a string s and string t, check if s is subsequence of t. You may assume that there is only lowercase English letter in both s and t. T is potentially a very long. Length is about 500,000 strings, and S is a short string below 100. A subsequence of a string is a new string which is formed from the original string by deleting some. Can be none of character without disturbing the relative position of remaining characters. ACE is subsequence of A, B, C, D, E, while AC is not. Let's check the example. As A is here, and then B is here, and then B is after A, yes. And then C is after B, yes. So return true. Check example 2. A, and then is there any X? No X, so return false. Okay, today I'm gonna implement 2A. First is base condition, and the second is I will also solve the follow-up. Follow-up is much difficult than easy, the base case, the base question. Okay, let's implement the code. First, see this one. I'm gonna use two-pointer technique. One pointer for S, and then the other point is T, and then I will iterate this pointer one by one. So first check with this one, is there any A's here, and then I move it to here. Next, now S pointer pointing B, and then iterate one by one. Now is it the same? Yes, same. So increase to C, and then check. In this time same. So now this is the out of bound. So pointer for S, pointer of S is out of bound. I will return true. Otherwise, I will return false. So I make pointer 1 is start from 0, and then for 2 I will iterating 2 in range length T, and if S1 is same as T2, I will increase 1. If 1 is same as out of boundary, I will return true. Otherwise, return false. Okay, let's edge case handling. If S is empty, this is okay, but this one is empty, but it's trying to access the 0, so it will be runtime error. So in this case, if length S is 0, I will return true first. Yes, true, because the empty space is subsequence of any words. Okay, looks good. Okay, great. In this time complex is there are one iteration, and then no data structure, so linear time with constant space. Okay, let's check with the follow-up. If there are a lot of incoming S, say S1, S2, to SK, where K is more than 1 billion, and you want to check one by one to see if T has its subsequence. In this scenario, how would you change your code? Okay, do you have any idea? Okay, first, I think that several question has some hint, very useful hint. So first, let's find the hint. That means T had its subsequence, means T is the what can I say? T is the did not change it. Only one T is provided, and then a lot of more than 1 billion as is provided. At this time, if we manipulate the T string, then maybe we will to make more fast to make the better code with the modified T. So which one is good? Now T is a string. Maybe we can also change it to array, set, or map. Which one is best? I think the start with the map is good because map has the value. So if we get some additional information from the T string, maybe we could use it. So this time I'm gonna use index of character. So like this. Map, I will use map keys character, and then value is array of indexes. So in this case, if there are more a, so 0, 1, 2, 3, 4, 5, this one is 6, this one is 7. In this case, we are able to make a has value is start from 0, 0, 6, 7. So okay, let's assume that as is A, B, A. In this case, we will use one more variable is the previous. Previous is the start with the -1, the out of index. So let's check the first letter, check A. A is exist, and then I will return the smallest updated 0. And then check the B. B is 0, 1, 2, or 0, 1, 2. So this time updated the previous is 2. And then next A, I will searching, is there any bigger number from 2? Yes, there are 6. So I will get it this one, and then update 6. And then one more time, we are also able to search, is there any number bigger than 6? Yes, 7. And then 7 return. At that time, we have to finish it, and then if there are no fault, we are able to return true. And then one more good thing is indexed is already ascending orders, because while we make the map, we will traverse the T, so index must be increased. Does it make sense? So we can able to use binary search. So we will traverse to find the bigger index than previous. We will use binary search. Okay. Okay, first I will make the map as global to prevent multiple creation while calling subsequence. Use init self, and then I will make self map. Means I will use collections default dig because value is the list, and then I will make the binary search. Receive the list and the target. I will implement later. Okay, let's implement the user subsequence first. First, let's make an alias. Map is self map, and then we need previous initialized out of bound index -1, And then first, if map is empty, I will fill data to map. So if length map is empty is 0, and then I will fill for I in range length t, and map ti append in each index. Now we fill the map, so it's time to checking the character in S. Yes, and then first, if that character does not exist in the T, we need to return. So character not in map. Map is the T of string, the character of T. So this time return first. And then next, previous is self binary search, and then nums is map character, and then target value. We needed to find a bigger number than previous, right? And then if we cannot find the number at binary search, I will return -1. If we cannot find the bigger number, that means that there are no character at the T. So that means -1, return first. And then I will increase previous by 1, because next time as characters increase 1, in this time previous also increase 6. Prevent you find the same value. And then if you pass all the cases, return true. Okay, now let's make binary search. Need to pointer left and right. Left is 0, right is length nums -1, while left equal right, because okay, mid is left plus right minus left divided 2. If nums mid is smaller than target, I will left move to mid plus 1. That means the target is here. Mid value is the smaller. That means the range we're looking for is the bigger than mid, right? So mid is enclosed? No, not enclosed. So that is the reason why I added 1. Else right also mid -1. And then if left is out of boundary, length nums, and return -1, because at that time we cannot find the value, the bigger than target. Means target is previous, right? Otherwise, return left. No nums left, because we needed to index number. Okay, let's check the code. Oh, looks good. Awesome. Okay, let's check the time complexity. This one is constant. Binary search take log n, and then in this time the filling t take big O at t, but it's just only one time of 1 billion, so we can skip it. And then okay, let's check the character. It take linear time, and then big O s, and then this one is big O t, but it's once in 1 billion, once per 1 billion. once, yes. And then t is, and then this one is the s, and then it also take log n, So time complexity is S log S. Then some people said, wow, this one is the bigger than linear time, right? Yes, that's right. But okay, let's check with this one. S is quite short, below 100, and then T is quite big, more than 500,000. So even time complexity is a little bit bigger, but length of S is quite smaller than T. So finally, the CPU time will be reduced. Does it make sense? Thank you.